Solve a question here right now. It says evaluate. This is Futo exam question. We are solving question number 4. Yes, it says evaluate using Simpson's 1/3 rule. The boundary integral from 0 to 1.2 x into bracket. So solution. Let's quickly do that. Solution without wasting much of our time. So this is the same thing as saying 0 to 1.2 of x into bracket 1 over 1 plus x squared, right? Dx, which is the same thing as saying integral of 0.1.2 into bracket x over 1 plus x squared dx. Because if you multiply this by means of multiplication, this means x over 1 times, so it's the same thing as this. All right, so now that you're able to interpret it, let's get the party started. So he said from 0 to 1.2. Now remember that h is 0.2. So let our f of x be x over 1 plus x squared, comma. We let our a be this particular person, 0. We let our b be 1.2. Is that not? That means that h is equal to b minus a over n, where n, we said where n is number of intervals. Let's not forget number of intervals. So this means that what we are saying 1.2 minus 0 divided by n is equal to, now they gave us h is 0.2. so to get n, we want to make n subject of formula, so n is equal to 1.2 divided by 0.2, and that gives us 6. Is that not? Okay, so having said that, let's get the party started quickly. So let's generate, we then begin to generate our table. That's step 2. Generate our table by putting x and y. So x here, so x, we're starting from, look at the integral, we're starting from 0, right? 0 to 1.2. so this is 0. What will be our next value here? Our next value is to add that 0 plus 0.2. Our next value there will be 0.2. Add 0.2 to 0.2, 0.4. Add 0.4 plus 0.2, 0.6, 0.8, 1.0, I believe 1.2. so I just keep adding the interval of difference in the h to everybody. Add h, keep adding the h to everybody there. Is that not? All right, so now our y, which is equal to f of x, we said when x is equal to 0, then our f of x, which is the same thing as y, is equal to x over 1 plus x squared. So what we are simply saying is that 0 over 1 plus 0 squared, 0 over 1, which is what? 0. Now, is that what? Which is 0. So this place is 0.00. So when x, let's be fast, we want to be fast. When x is equal to, when x is 0.2, our f of x is equal to x over 1 plus x squared, which is the same thing as 0.2 divided by 1 plus 0.2 all squared, which will now be 0.1923. You can confirm that with your calculator. So that was how we're able to fill in this particular space, and we said here is 0.1923. the next one will be 0.3448. the next one will be 0.4412. the next one will be 0.4878. next one will be 0.50. next one will be 0.4918. yes, that was how. So if you want to do that, you can say when x is equal to 0.4, f of x was, I'm just trying to babysit you here right now, 0.4 divided by 1 plus 0.4 all squared. You're gonna get 0.3448, something like that. When x is 0.6, f of x, just follow the pattern, right? 1 plus 0.6 all squared you have 0.4412, you know, and so forth, and so, you know, like that. That was how this table was filled. That was how this particular table. Meanwhile, we are solving a Futo question 2024 to 2025, exam question number 4. Exam question number 4. All right, so having done that, having generated your table, we now apply the Simpson's rule, which says that I is equal to h over 3 into bracket yn, y0 plus yn. This thing means ending. The thing at the end. This one is at the beginning, at the end. All right, this one beginning, this one end, plus 4 into bracket the sum of odd coordinates, abi, plus the 2 into bracket the sum, right, of even coordinates. Is that not? And then we do this. So I is equal to, what is our h? Our h was 0.2. It was given in the question. 0.2. We are saying 0.2. We are saying 0.2 divided by 3 into bracket. Why not? What is why not? Please, class, for the sake of time. This is why not. This is y1, y2, y3, y4, y5, and y6. Is that okay? So y naught in this case is what is that? That is 0.00. Okay, 0.00. What is at the end of the table? Yn. At the end is 0.4198. 0.4918. Is that correct? Is that correct? 0.4918 plus 4 into bracket sum of the odd coordinates. What are the odd numbers that we have here? Who can tell me? What are the odd numbers that we have here? That's at y1 is an odd number, 1 is an odd number, 3 is an odd number, 5 is an odd number. Is that not? So 0.1923, 0.1923 plus 3 is an odd number, 0.4412 plus 0.5000. I mean, then even numbers are 2 is an even number. These are even numbers, and 4 is an even number, right? 4 is an even number. So 0.3448, 0.3448, 0.3448 plus 0.4878. I mean, so I is equal to, if you break that math down, right, you have 0.2 over 3 into bracket 0.4918 plus 4.5340 plus 1.6652. You can also fact check me. Is that okay? So I is equal to 0.2 divided by 3 into bracket 6.6910. So approximately 0.4461. That's what you're supposed to get as your answer. But you see, the question is a 2-in-1 question. The question is a what? It's a 2-in-1 question. It says, the second part says, it said compute. Do you see that? It says compute ln 2.44. So we are aware that if you have an integral of x of 1 plus x squared dx, if you have this integral, you can say, okay, so let u equals 1 plus x squared, right? And so du dx is 2x. So this is the same thing as saying x divided by u, right? So because you want to write dx now, you're going to make dx out of formula. I'm going to make dx out of formula here. If you divide by this, so this is du is equal to dx times 2x, abi? So divided by 2x, divided by 2x. So this one cancels this. I'm going to have dx is equal to du over 2x, abi? So integral of this times du over 2x, abi? So this x cancel this one, abi? So we are having an integral of 1 over 2u du. Yes, 1 over 2u du, abi? Okay, so now if we have an integral of 1 over 2u du, then we can now say that what this is equal to 1 over 2 ln, because you see, if you say integral of 1 over u, the answer to that question is ln u. So it's ln u. So we say integral of 1 over 2u du is same thing as saying 1 over 2 times integral of 1 over u du. I mean, that's 1 over 2. What is integral? That's ln u, right? Ln u, right? Ln u plus c. Most of you say ln u plus c. So let's just say ln u plus c. But this time we're not using this arbitrary constant. We still have a lot of work to do. So we have 1 over 2 ln u. But I said take u ln 2.44, right? Ln 2.44. But u was what in the first place? U was 1 plus x squared. So we have 1 over 2 ln 1 plus x squared, right? 1 plus x squared. So we want to compare. So and don't forget we are evaluating from 0 to let's do this. We are saying 1 over 2 ln 1 plus x squared. We are evaluating from 0 to 1.2. Yes, from the integration that you had. Yeah, integrated from 0 to 1.2. Don't forget that. So this will later become 1 over 2 ln 1 plus 1.2 squared. Did you know how I got this? How did I get this? I compared 1 plus x squared. I compared it with 2.44. I said ln 2.44. You understand me? So if you subtract this, you're going to have this. Subtract 2.44 minus 1, you're going to have so if you compare it, this is what you're going to have. Do you understand? Yes, this is what you're going to have. So 1 plus 1.22 squared, because 1.22 squared times 1.22 is about 1.44. 1.22 or 1.2, sorry, times 1.2, I think it's about 1.4. I mean, is it 1.44? Yeah, something like that. Just know that the square of it, let me confirm that quickly. 1.2 times 1.2 times 1.2, that's 1.44. Yeah, we're correct. So 1.44 plus 1, that's 2.44. That was how I was able to get that particular part to so I compared it with this person. You understand? When you compare it like that, you're gonna get this. So when we do that, ln 1 plus 1.2 all squared, right? If you do this, the boundary integral, what you are simply saying is 1 over 2 ln 1 plus this minus minus 1 over 2 ln 1 plus, this is basic integration, right? This is basic integration. Yes. So our answer I will be 1 over 2 ln 2.44 minus 0. So we have I is equal to, what is ln 2.44? Let's confirm that. ln 2.44 is computed, that's 0.891. 0.891. 1 over 2, 0.891. Is that okay? Yes, 0.891. So okay, so if we divide this, we're still gonna have 0.891 divided by 2. 0.891 divided by 2, we're gonna have 0.4455. So you see that here we had using the Simpson's 1/3 rule, we have 0.4461. This one is approximately 0.45, right? 45. The 2 decimal place. This one is also approximately 0.45. Okay, so you can see that It is correct, right? It is correct. Very interesting. So this is how to solve the Maths 209 2024-2025 question number 4.